Hey, this is Professor Perez from Saddleback College. Today we're going to do something called Kung Fu fractions. Actually, it's called clearing fractions, but some of the students call it Kung Fu, so I guess we'll use that. Anyway, let's see what Charlie's up to. He says he loves to Kung Fu. He better be ready to go.
Don't quit fooling around and sit down.
All right, anyway, let's get started here. Let's get started with some Kung Fuing now. Now, before you start Kung Fuing, you have to know what you're doing. So we're going to explain what it is first, and then we'll go into some Kung Fu, or clearing fractions. All right, Charlie, pay attention right there. 4 times 3/4. So let me walk you through this first one, Charlie. Notice we're going to take the 4 and write it as a fraction, 4 over 1 times 3/4. And notice the 4's will reduce, right? They both become 1s because they're divisible by 4. And notice on top, when we multiply straight across the top, straight across the bottom, we end up with 3 over 1, which is what, Charlie? 3. So really, 4 times 3/4 ends up being a whole number. There's no more fraction. And so it was cleared, or Kung Fu. Now watch this, Charlie. 8 times 3/4. Now notice here, we have 8 over 1 times 3 over 4. And Charlie, we can reduce the 8 and the 4. How does that reduce? 2 over 1. 2 over 1. And notice the denominator is going to be 1, and the numerator will be 6, just like that. And so our answer is 6. Again, we have a whole number. The fraction was cleared out. We'll do one more here with 12. 12 times 3/4, we write it as 12 over 1 times 3/4. The 12 over 4 reduces by 3 over 1. And now on the top, we end up with a 9, on the bottom a 1, and again, a nice whole number. So notice here, with all these fractions, those denominators divide evenly into those whole numbers being multiplied to the fraction. And when that happens, that's when you can Kung Fu. All right, go ahead, Charlie. All right, calm down over there. Okay, so let's kind of review what we just did here. 4 times 3/4. Notice the 4's cancel out. 4 goes into 4 one times. That's when you want to think of it. It just comes up 1, and 1 times 3 is 3. There's our answer there. That was the first one. In the second one, 8 times 3/4, you can just simply think 4 goes into 8 2 times, right? That's how it reduces, and then 2 times 3 is that 6. Okay, now we're starting to clear fractions a lot more efficiently. This is called Kung Fu. All right, 12 times 3/4, Charlie. 4 goes into 12 how many times?
3 times.
3. And 3 times 9 is?
What?
9. That's right. 3 times 3 is 9. Okay. All right, so now, like I said, before you start Kung Fuing, you need to know and understand what you're doing. So, Charlie, can we Kung Fu this one?
Yes.
No, Charlie, you just got beat up.
What?
See, you have to know what you're doing. You have to know when and when you cannot use Kung Fu, because otherwise I'm going to Kung Fu your grades.
What?
All right, Charlie. No, you can't Kung Fu this one. So we'll write it 5 over 1 times 3/4, because the 4 doesn't reduce with that 5, right? And so you just multiply straight across the top, straight across the bottom, and notice we get 15 over 4. The fraction did not go away. All right. How about this one, Charlie?
Yes.
No, you cannot Kung Fu this one, Charlie. 9 does not go into 3. It will reduce, but not the way you're thinking. Watch. Let's write 3 as a fraction, 3 over 1 times 2 over 9. And notice the 3 and the 9 will reduce. But notice, Charlie, you do not have a 1 on the bottom this time. So on top, you have 1 times 2, which is 2. And on the bottom, 1 times 3 is 3. It did not reduce, right? It did not come out to be a whole number. So be very careful. All right, Charlie. Let's see if you get this one right.
Yes.
All right, that's better. Yes, because the 3 will divide evenly into that 15, right? Okay, so the 15 over 3 reduces to 5 over 1. We have a 1 in the denominator, so we can disregard it. And 5 times 4 is what?
20.
20. Very nice there, Charlie. All right. Let's try this one. 8 times 7 over halves. Yes.
2.
Because 8 over 2 reduces to 4 over 1. 4 times 7 is 28 over 1, which is 28. Very nice. Let's do 12 times 4, 5/4. Yes or no, Charlie?
Yes.
All right. Now the 12 over 4 reduces to
3 over 1.
3 over 1. 3 times 5 is
15.
15 over 1, which is just 15. Very nice. Now 12 times 7/3, Charlie?
3 goes into 12. 4 times 7, 28.
Very nice there, Charlie. That is true. Now, I know you're all thinking, well, it doesn't always work out where you have a number in front that's going to be divisible by that denominator. Well, that's true. So, let's look at an application of Kung Fu fractions here. Now, 2/3 plus 3/4, Charlie, we can't add them together because they do not have the same denominator. Well, what is the LCD here?
12.
12, that's right. Now, we're going to apply some Kung Fu to this. Watch. Now, remember, Charlie, 1 times anything doesn't change anything, right? It's still itself. So we're going to take that 1 and we're going to rewrite it as 12 over 12, which is our LCD, right? Our LCD is 12, so we're using the LCD to rewrite the 1 as 12 over 12. And now what we're going to do, Charlie, is we're going to take that numerator, which is a 12, and we're going to distribute into the parentheses, just like this, right? And now, don't forget, outside, we still have the 1/12. All right. Now, here we go. We can start Kung Fuing, Charlie. What's 12 times 2/3, Charlie?
8.
That'll be 8. That's right, just like that. Now, how about 12 times 3/4, Charlie? What do you get?
9.
That's 9. That's right, because the 12 and the 4 reduce to 3 over 1, and you're left with the 9 on top. And now, notice, all you have to do is add the 8 plus 9, which is 17. And don't forget, since you got the 1/12 outside, 17 is 17 over 1 times 1/12 is 17 over 12, and that's it. Kung Fu. All right, here we go, Charlie. So let's do another one. Let's step it up a bit. Don't get scared. You just got to use that LCD. Watch. All right, Charlie, what is the LCD here? Now think about this one.
8.
Very nice there, Charlie. It is 18. That was a tough one. Now again, remember, if we multiply anything by 1, it doesn't change it. So we're going to rewrite that 1 in the front of the parentheses as an 18 over 18, and we're going to distribute that numerator 18 into the parentheses. Just like that. And don't forget, outside, we still have the 1/18. And now, here we go. We can Kung Fu. Okay, Charlie. 18 times 8 over 9. 9 goes into 18. How many times, Charlie?
2.
2, that's right. And 2 times 8 is 16. Let's go to the next one. 3 goes into 18 how many times?
6.
And 6 times 2?
12.
Very nice. We go to the next one. 2 goes into 18 how many times, Charlie?
9.
That's right. And 9 times 1 is 9. And the last one, 6 goes into 18.
3 times.
And 3 times 5 is 15. There we go. So now we just have arithmetic. Now, in the parentheses, Charlie, you just have to do 16 plus 12, subtract 9, subtract 15. All right, Charlie, start working on it. This is a tough one. Oh, he's working hard. Let's not distract him. All right, Charlie, time's up. What'd you get?
4.
4. Very nice. And don't forget, we have the 18th, 1 over 18 outside. So bring that in. Our answer is 4 over 18, which does reduce to what, Charlie?
2 9s.
2 over 9. Very nice there, Charlie. That was some good Kung Fu here. Now, as you practice, you'll get better and more efficient at it. So let's just take a look really quickly how a black belt would do this. Watch. Same problem, 2/3 plus 3/4. Pay attention, Charlie. They see that the LCD is 12, and this is what they do. 3 goes into 12 4 times. 4 times 2 is 8. And then 4 goes into 12 3 times. 3 times 3 is 9. And so it's 8 plus 9 over 12, which is 17 over 12. There you go. Very efficient here. It looks like you're cheating, huh? Well, anyway, let's do it one more. Bring it home. 8 9ths. LCD is 18. Here we go. 9 goes into 18, 2. 2 times 8 is 16. 3 goes into 18, 6. 6 times 2 is 12. 2 goes into 18, 9. 9 times 1 is 9. 6 goes into 18 3 times. 3 times 5 is 15. There we go. All over 18, and you do your arithmetic. It's 4 over 18, which reduces to 2 9ths. Kung Fu. Anyway, we'll see you all again soon.